In the earlier chapter, we studied reflection at plane surfaces. Like reflection from a plane mirror. In this case, we'll study reflection at spherical surfaces. A spherical surface like this, you see, is formed when you take a sphere and cut it into small parts. Each part of the sphere can then be used as a mirror. So if you cut the sphere such that you make the inside portion of the sphere as the reflecting material, then you get a concave mirror. So the reflecting surface in a concave mirror is concave in shape, as you can see here. The center of the sphere from which the piece has been cut is called the center of curvature. So this here is the center of curvature. The middle point of the piece is called the pole, P here, and there's a point called focus between the center of curvature and the pole, and we'll talk a lot about this point focus later on as we proceed. And the line that joins the center of curvature, this focus, this pole, is called the principal axis. And what will happen if you don't create a reflecting surface on the inside part of the sphere, but what if you create a reflecting surface on the outside part of the sphere? Then something like this will be formed, right? As you can see, the outside part of the sphere is reflecting in this case. Again, as you can clearly see, this is the focus here, this is the radius of curvature, and this is the pole. And this axis, as you already know, is the principal axis. Now what we'll really do in this chapter is study exactly what happens to rays when they are incident on a concave mirror and a convex mirror. So for example, if rays are coming, like this here, what will happen? Where will these rays go? That's what we'll study. But before we study all that, we'll have to learn about sign conventions. In case of spherical mirrors, there's this very strict rule about which sign to use when. So the direction of the incident ray, for example, is always considered to be positive. This means if you're solving any problem, and let's say you have to include this focal length here, you'll say minus f is the focal length. Why minus f? Because the incident ray will always travel towards the right, so any distance towards the left will be negative. So the distance of the center of curvature here will be indicated as minus r, and the distance of the focus from the pole will be minus f. Similarly, this direction here will be positive. So if you have to indicate, say, the height of an image or the height of an object, if there's an object here, for example, then the height of the object will be written as plus h. Similarly, if the object height is like this, then its height will be minus h. So as you can see, the sign convention says that the direction above the principal axis, this is the principal axis, is positive, and the direction below the principal axis is negative. There you go.